Okay, so the last one ran out of time, but we're starting off where we left off there. So just to quickly review, the principal quantum number, that's just the number of shells you have. So for example, in the case of sodium we were talking about, how sodium has 1, 2, 3 orbitals that we have in the Bohr model. So N for sodium, N would equal 3. For the angular momentum, that's L, I can have, based on my N, I can either have 0 all the way up to N minus 1. So in the case of when I have an N of 3, like in sodium, I can have 0, I can have 1, and I can have all the way up to 2 because 3 minus 1 is 2. And these numbers are going to correspond to my S, P, and D orbitals that I looked at the shapes of before. So for example, the S being the circle ones, the sphere, the P being those little dumbbell ones that can either exist on the x-axis, the y-axis, or the z-axis. Right, so these are my P, and I'm not going to even try to draw the D and the F, but those would be for my L's of equal to, so this would be L of 0, this would be my L of 1, then D would be L of 2, and F would be L of 3, for example. Okay, and then furthermore, within those SPD orbitals, the quantum numbers of L, I can have a magnetic quantum number, which is abbreviated M sub L. And this is going to be the orientation of the orbital in space relative to the other orbitals. You don't really need to understand what it actually means, but what you do need to know is that if I have an N of 3, basically from the highest L that I have based on my N, so if I have an N of 3, the highest L I would have is 2. I can go all the way from negative L all the way to positive L for my M orbitals. Okay, so that sounds complicated, but it's not. So again, N, just straight up my Bohr number, my number of Bohr orbitals. N minus 1 gives me my L's. My M number, or M sub L, is going to be from minus L to positive L. So what does that mean? If I have an L of 2, my highest L is 2, I can have negative 2, I can have negative 1, I can have 0, I can have positive 1, and I can have positive 2. Okay, so let's try and redo all of this as if I had an N of 4. Okay, so I'm going to erase all this, hopefully. Oh, this is going to take forever. There we go. So let's do this as if we had an N of equal to 4, which would be something on period 4 of the periodic table. So let's say we have, N equals 4. So if N equals 4 and L is equal to all my numbers from 0 up to N minus 1, then my L's are going to be 0, right, which remember is S, 1, which is P, 2, which is D, and 3, which is F. Because 3 is N minus 1, which is 4 minus 1. Okay, so these are my L orbitals. So that tells me I have an S, P, D, and F orbitals. And then my M sub L is going to be from my highest L, negative L to positive L. So I would have, for my M, I would have negative 3, negative 2, negative 1, 0, 1, 2, and 3. And again, these are just increasing levels of specificity. So this is telling me, okay, well, these are the orbitals I have in general, but then within each of these quantum numbers, I have these momentum quantum numbers, or L's, and then furthermore within each of these L's, I can break them down into these magnetic quantum numbers. Okay, so this is what that looks like. So here for the 4 possible N's. So again, L can be anywhere from 0. 0 is the lowest L you can have. That's your, remember that tells you the shape of the orbital. So 0 is S. So this is S. This is S. This is S. 1 is my P orbital, my P-shape orbitals. So all my 1s are P-shaped. All my 2s are D-shaped. And all my 3s are going to be those F. Okay, so this is going to correspond, so let's look at sodium again. Remember sodium had 11? So we said that sodium was 1s2, 2s2, 2p6, 3s1. So this is telling me the information. So in the first orbital, so my n equals 1, I have 2 electrons. They're all found in an s orbital. Then I go up to the next, right? So I have my first one. So here's the nucleus, right? And then around it I have that one s orbital, and that's going to have those 2 electrons. Then I have another s orbital around it. That's my second quantum number, and it's another s, so it's that shaped, and there's 2 electrons in there. Then I have my p orbitals. So remember, the p orbitals are going to be shaped like this. So I can put 2 electrons, 4, 6 electrons in the p orbitals, and then I go to the third shell and I have another s that's going to encapsulate all of those. Right, so this is just giving me, again, a detailed information about where the electrons are found. And this is what sodium would look like. So it would have 2 electrons in the innermost s shell, 2 electrons in the second, so the second s shell. Then when I get to my third one, then 6 electrons in those p shells, right? Each one of them can hold 2, and I have 3 of them, so that's 6 electrons. And then I go to my 4s shell. So what if I had to keep going? So I can fit 2 electrons in this 3s shell. I could fit 2 electrons, but if I had another electron, I would have to go to another set of p shells. So there would be more p shells outside, and those would be my 3p. So I would have my 3p in this direction. I would have my 3p in this direction. I would have my 3p in this direction, and then I'm going to start getting into my d orbitals, and it gets more complicated. So again, my n, my L, which goes from 0 up to n minus 1, so 2 minus 1 is 1, 3 minus 1 is 2, 4 minus 1 is 3, and then my m sub L is going to be equal to my largest L from negative that number all the way to my largest L to positive that number. So for 0, that's just 0, which is why I only have s orbitals. For n equals 1. For n equals 2, 0, that gives me my negative 1, 0, positive 1. So now I've introduced the p orbitals and so on. So let's try one together. So the principal quantum number 3, determine the number of allowed subshells, which are different values of L, and give the designations for each. So n equals 3, which means to calculate my L, so remember this just tells me my Bohr level. This is like telling you that I live on Earth. And then from there, I'm going to do n minus 1 is going to give me my L's. So my L's are going to be starting at 0 and then 1 and 2 because n minus 1 is 2. Then for the M's, right, and again, this would be my S, P, D. Keep going, sorry. So for my, what's the level, next one? Oh, M sub L. I can go all the way from negative, the largest number, so it's negative 2, negative 1, 0, 1, 2. Okay, so number of allowed subshells. So for 0, I only have S. For 1, I extend up to P, and for 2, I can extend up to D. So 1, 2, 3, and so on. Okay, so what did those actually tell me? So again, the L told me the shape of the orbital. So S is a circle, or sphere, so I like to think S for sphere. P, it's these kind of dumbbell-shaped ones that go along the XY axis. So we have, XYZ axis. And I think that we're talking about 3-dimensional space, which is why we have a Z axis. So we have X, Y, and Z. And so the P's that go around the X axis we call P sub X. The ones that go on the Z axis we call P sub Z. And the ones that go along the y-axis we call P sub y. And then for D and F, I like to think of it this way because it starts to get so complicated in terms of the shape. You just really need to remember it. And so to remember that D is complicated, I just remember it like dang. D is for dang because it starts getting too complicated in the shapes. And then when I get to F, it's just like fuck. right? I didn't say it though. Anyway, so this is where we're going with this. This is in a nutshell what you need to know. There is some math, and we'll talk about that in more specifics. And I'm going to post more videos that do a much better job of explaining this than I do. But again, this is just my broad 50,000 foot view.